The National Electrical Code, often referred to as the NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It's developed and published by the National Fire Protection Association, or NFPA, and is widely adopted by states and municipalities to ensure safe electrical practices. Understanding the NEC is crucial for electricians, electrical engineers, contractors, inspectors, and anyone involved in the design, installation, and maintenance of electrical systems. The primary purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. It establishes minimum requirements for electrical wiring, equipment, and installations, covering a wide range of topics from grounding and bonding to overcurrent protection and wiring methods. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and reflect changes in industry best practices. This regular revision cycle ensures that the code remains relevant and effective in addressing evolving electrical hazards. The NEC is organized into chapters, articles, and sections, each addressing specific aspects of electrical installations. Chapter 1 provides general requirements that apply to all electrical installations, including definitions, scope, and enforcement provisions. Chapters 2 through 7 cover specific wiring methods, equipment, and occupancies, such as residential, commercial, and industrial buildings. Chapter 8 addresses communications systems, while Chapter 9 contains tables and examples that are used throughout the code. Several key concepts are fundamental to understanding and applying the NEC. Grounding and bonding are essential for preventing electrical shock hazards and ensuring that electrical equipment operates safely. Grounding provides a path for fault current to return to the source, tripping over current protective devices and energizing the circuit. Bonding connects non-current carrying metal parts of electrical equipment together to create a low impedance path for fault current. Overcurrent protection is another critical aspect of electrical safety. Overcurrent protective devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds the rating of the circuit, preventing overheating and potential fires. Wiring methods specify the types of conductors, cables, and raceways that are permitted for different applications. The NEC provides detailed requirements for the installation of these wiring methods, including ampacity ratings, derating factors, and support requirements. The NEC also addresses specific requirements for different types of occupancies, such as residential, commercial, and industrial buildings. These requirements take into account the unique electrical hazards associated with each type of occupancy. For example, residential occupancies have specific requirements for ground fault circuit interrupter, or GFCI, protection in bathrooms, kitchens, and other wet locations. Commercial occupancies have requirements for emergency lighting, fire alarm systems, and other safety-related equipment. Industrial occupancies have requirements for hazardous locations, such as areas where flammable liquids or gases are present. To effectively use the NEC, it's important to understand how to navigate the codebook and find the information you need. The NEC includes a detailed table of contents, an index, and cross-references that can help you locate specific requirements. It's also helpful to familiarize yourself with the structure of the code, including the chapter, article, and section numbering system. The NEC is not a design manual, and it does not provide detailed instructions on how to design electrical systems. Instead, it sets minimum requirements for safety, and it's up to qualified electrical professionals to design and install electrical systems that meet these requirements. It's also important to note that the NEC is not a substitute for sound engineering judgment and experience. Electrical professionals must use their knowledge and expertise to ensure that electrical systems are safe and reliable. The NEC is constantly evolving to address new technologies and emerging safety concerns. It's important to stay up to date on the latest changes to the code to ensure that your electrical installations are compliant and safe. The NFPA offers a variety of resources to help you stay informed about the NEC, including training courses, publications, and online forums. Some specific examples of NEC articles and their relevance are Article 210.12, which pertains to arc fault circuit interrupter or SI protection. This article mandates the use of size in specific locations within dwelling units to protect against electrical fires caused by arcing faults. Article 230 covers service entrances, outlining the requirements for bringing electrical power from the utility company to a building. It addresses issues such as service conductor size, overcurrent protection, and grounding. Article 250 deals extensively with grounding and bonding, providing detailed rules for establishing effective grounding systems to minimize the risk of electrical shock and ensure proper operation of overcurrent devices. Article 300 provides general requirements for wiring methods, addressing issues such as protection against physical damage, securing and supporting cables, and proper installation techniques. Article 310 focuses on conductors for general wiring, specifying ampacity ratings, insulation types, and other characteristics that affect the safe and efficient use of conductors. Article 400 covers flexible cords and cables, outlining their permitted uses, limitations, and proper installation methods. Article 430 deals with motors, motor circuits, and controllers, addressing issues such as motor protection, overload protection, and control circuit wiring. Article 440 specifically addresses air conditioning and refrigeration equipment, providing requirements for disconnecting means, overcurrent protection, and wiring methods. Article 500 through 516 contains articles covering hazardous locations, classifying areas based on the presence of flammable gases, vapors, dusts, or fibers, and specifying appropriate wiring methods and equipment for each class and division. Article 547 covers agricultural buildings, addressing the unique electrical hazards associated with livestock confinement areas and other agricultural environments. The NEC uses a system of tables to provide detailed information on various aspects of electrical installations. For instance, Table 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts, based on the conductor size, insulation type, and ambient temperature. These ampacity values are essential for selecting the correct conductor size to carry the intended load without overheating. Table 250.122 provides the minimum size of equipment grounding conductors for grounding raceway and equipment. This table ensures that equipment grounding conductors are sized appropriately to provide a low impedance path for fault current. Table 430, 148, 430, 149, and 430. 150 provide full load current values for alternating current, or AC, single-phase, two-phase, and three-phase motors, respectively. These tables are used to determine the appropriate size of motor overcurrent protection devices and conductors. The NEC also includes examples and calculations to illustrate how to apply the code in specific situations. These examples can be helpful for understanding complex requirements and ensuring that electrical installations comply with the code. Annex B provides examples of conductor ampacity calculation adjustments for ambient temperature and the number of conductors in a raceway. These examples demonstrate how to apply the dirting factor specified in the NEC to ensure that conductors are not overloaded. Annex D provides examples of branch circuit, feeder, and service calculations for various types of occupancies. These examples illustrate how to calculate the demand load for an electrical system and select the appropriate size of conductors and overcurrent protection devices. Several organizations offer resources and training on the NEC. The National Fire Protection Association, or NFPA, offers a variety of training courses, publications, and online resources related to the NEC. These resources can help you stay up to date on the latest changes to the code and learn how to apply it effectively. The International Association of Electrical Inspectors, or IE, is another organization that provides training and certification for electrical inspectors. The IE also publishes a variety of resources on the NEC and electrical safety. Electrical trade unions such as the International Brotherhood of Electrical Workers, or IBU, offer apprenticeship programs and continuing education courses for electricians. These programs provide comprehensive training on the NEC and other aspects of electrical work. Online resources such as websites, forums, and online training platforms can also be valuable sources of information on the NEC. However, it's important to ensure that the information you're accessing is accurate and up to date. The NEC is enforced by local and state electrical inspectors. These inspectors review electrical plans and inspect electrical installations to ensure that they comply with the code. It's important to work closely with electrical inspectors to ensure that your electrical installations are safe and compliant. The NEC provides specific guidelines for electrical installations in healthcare facilities to ensure the safety of patients and staff. These guidelines address issues such as essential electrical systems, grounding, and isolation power systems. Article 517 provides detailed requirements for electrical installations in healthcare facilities, including hospitals, nursing homes, and clinics. It covers issues such as essential electrical systems, which are designed to provide backup power in the event of a power outage. It also addresses grounding requirements to minimize the risk of electrical shock hazards in patient care areas. Isolation power systems are used in critical care areas to isolate patients from ground faults and reduce the risk of micro-shock hazards. The NEC also includes requirements for renewable energy systems such as solar photovoltaic or PV and wind power systems. These requirements address issues such as grounding, overcurrent protection, and disconnecting means. Article 690 provides detailed requirements for solar PV systems, including requirements for inverters, charge controllers, and energy storage systems. Article 694 covers small wind electric systems, addressing issues such as turbine installation, grounding, and overcurrent protection. The NEC also addresses the specific electrical needs of data centers and other information technology or IT equipment. These requirements address issues such as grounding, bonding, and power quality. Article 645 provides requirements for information technology equipment rooms, including requirements for disconnecting means, overcurrent protection, and grounding. It also addresses issues such as power quality and the need for uninterruptible power supplies, or UPS, to protect sensitive IT equipment from power outages. The NEC also includes requirements for electric vehicle, or EV, charging stations. These requirements address issues such as grounding, overcurrent protection, and disconnecting means. Article 625 provides requirements for EV charging equipment, including requirements for the location of charging stations, the type of connectors used, and the level of overcurrent protection required. It also addresses issues such as load calculations and the impact of EV charging on the electrical system. The NEC also covers temporary electrical power for construction sites and other temporary applications. These requirements address issues such as grounding, overcurrent protection, and wiring methods. Article 590 provides requirements for temporary electrical power, including requirements for ground fault protection for personnel, or GFCI protection, and the use of weatherproof enclosures. It also addresses issues such as the inspection and maintenance of temporary electrical systems. The NEC also addresses the safe installation of swimming pools, hot tubs, and spas. These requirements address issues such as bonding, grounding, and ground fault circuit interrupter, or GFCI, protection. Article 680 provides requirements for swimming pools, hot tubs, and spas, including requirements for bonding all metal parts of the pool structure, grounding the electrical equipment, and providing GFCI protection for all electrical outlets within a certain distance of the water. The NEC is an essential resource for anyone involved in electrical installations. By understanding the code and staying up to date on the latest changes, you can help ensure that electrical systems are safe and compliant. Remember to always consult with a qualified electrical professional for any electrical work you are planning.